Our speaker today is Tim Kelsey, a professor of agricultural economics at Penn State University, who conducts research on the economic and community implications of Marcellus shale, land use change, public finance, and taxation. He has extensive experience across Pennsylvania conducting economic analyses and presenting informal workshops for local government officials, the business community, and others on these issues. He currently teaches courses on community-based research methodologies, economic development tools, and community development, and has been at Penn State since 1991. I'm now going to turn it over to Tim to share some of his recent work focusing on the economic impacts of bioenergy in Pennsylvania.
Very good. Thank you, Sarah. I appreciate very much the invitation to talk with you today, and I hope you find the information I present of interest to you. The research I'm going to present is based on a report that the last slide shows. It's available on the web, and there's a URL so you can go access that if you want to read it in depth. But the study was conducted by myself, Emily O'Cunahern, who's an undergraduate student here at Penn State University in the Community Environment and Development Program, and Dave Swenson, who's a researcher at Iowa State University and has been involved in similar analyses both in Iowa. He conducted one of the major studies up in New York State and in other parts of the country as well too. So the three of us worked on this together. What I intend to do is go through. I'll give you a little bit of a background on what we were intending to do. A little bit on kind of a quick primer on economic impact analysis, and so you can understand kind of the numbers and how far you can push these. We'll talk a little bit about how we set up the analysis, the data that went in, and then I'll present the results and talk briefly about the implications. Then we'll open it up for questions from you. This project was done for the New Bio project. We're not formally part of New Bio, but based on the work that's been done, there are questions about if such development was done in Pennsylvania, what would be the economic impacts? And so the analysis we did was a way to help support the New Bio project efforts. The request of the New Bio, we considered three major feedstocks: Willow, Switchgrass, Miscanthus, as the options for providing the feedstock for the plants. And you'll see the reports that we did analysis for each separately. In reality, the impacts, if a plant was a blend of, say, willow and switchgrass, the economic impacts would be a blend between the combination of the analysis that we run separately for each. What we did as this scenario is, with the three feedstocks, we considered 4 different locations in Pennsylvania. I'll talk in a couple moments about how we identified those locations. Based on discussions with some of the folks from New Bio, based in part on Dave's experience in Iowa, we chose to model a 25 million gallon size plant. So that was the main kind of economic activity. Supporting that, and go into the indirect and induced effects as well too, as well as the associated crop production, storage, and transportation to provide the feedstocks to the operating plants. And so we can talk a little bit later if you want about what the implications would be if there were larger plants or smaller plants. But this is when you see the results, we're assuming the 25 million gallon plant, which is kind of consistent with a lot of the work that's been done in Iowa. The basis for the analysis, we used the economic impact model, input-output model called IMPLAN. It is the most widely used economic impact model that is used in the United States. It's been around for 30-some years. It was originally developed by the U.S. Forest Service. It's been updated. It's been privatized, and actually there's a typo there, so it should say now privately updated, not privately updated. It's now privately updated annually. What's nice about the analysis is it allows you to do some fairly rigorous analysis at individual county level, at a multi-county level, that provides a variety of results, both employment, output, income, a variety of other things that are of interest. And then something else that I like about it is, because it is so widely used, there's a lot of other studies that are out there that have used it, and so it makes it easy to compare the results here in Pennsylvania, say to New York or to other places, to get a sense of how realistic are the estimates, how consistent are the estimates. Something you can't do if the tool used for the economic analysis was unique to each individual location. That you're not able to make those comparisons. So that was the specific model we used. Now, a basic principle behind economic analysis is economic impact analysis is you're trying to look at and identify what are the multiplier effects. And what we mean by that is for a dollar that's spent in a community, how much of that dollar stays within the community and is respent versus how much leaks away or is spent elsewhere, and so it doesn't have a chance to recirculate. And so what I have here is a kind of a fairly standard diagram that you'd see often in undergraduate level class talking about economic impacts. If the initial spending, and here we're talking about the labeling as exports, if you look at the initial spending, say by an ethanol plant, what the model does is it looks at and says, based on that initial dollar spent, how much of that dollar was actually spent within the county or the counties which we're studying, and how much was spent outside of those counties. And so in other words, spending internal to the county would be to the extent that they're buying the feedstocks within the county, to the extent that the employees live within the county versus commuting into the county from outside the county. Janitorial services, supplies, maintenance equipment, other kinds of things. All those, some of those items can be purchased locally. Some have to be brought in from outside the community. What the economic impact model does is it traces through, based on secondary data, how those dollars will turn over within the community. So that initial spending, how much is respent in the community, how much leaks out initially. And what this implies very much is that an economic impact model, the overall structure can be common like IMPLAN, but the actual model itself has to be uniquely constructed for each individual study you're doing, each individual county, simply because the local economies vary. How many janitorial, how many farms, how many transportation firms, how many, the role of local government. So it varies between counties, and so how much an individual dollar would stay within the community versus leaking out immediately varies by individual counties. So what we did for the sake of this analysis is we looked at the 4 locations, and we used IMPLAN to create a unique model for each of those individual counties that we then ran the numbers through. And the thing you'll notice with the results is the results are different across the counties, and the reason they're different is because the local economies are different, and thus, a dollar spent locally, depending on the community, it's going to be respent. It's going to multiply differently, simply because the mix of local businesses and so on vary quite a bit. I realized one thing I forgot to mention with the previous slide, and this is very critical. Our focus here was economic impact, which is essentially the question, if this thing is built and it operates, what will be the economic effects within the community? Employment effects, income effects, overall output effects. That kind of analysis is very, very different than what you could call a feasibility analysis, financial feasibility, economic feasibility. The latter kind of analysis asks the question, if this was built, would it be profitable? Would it be able to stay in business long run? We did not consider the feasibility question. And so when you look at the numbers, the big caveat to keep in the back of your mind is the assumptions behind the numbers are, if these are built and operate, this will be the impact. But the absolutely critical question is, if they were built, would they be profitable? And that's something that's different than what our original charge was. So that's a caveat I'll come back to later in this presentation. With economic impact analysis, generally there's 3 types of broad effects that are talked about. There's the direct effects. In this example, and you see the way we modeled it is we said, okay, if you've got a plant that produces 25 million gallons a year, what are the employment, what's the output, what's the income effects of the plant? So those are within the operating plant itself. Economic model also estimates what are called the indirect effects. And what those are is the effects of, if you've got the plant operating, the plant obviously is buying goods and services from other firms. It's buying, as you said, feedstocks, janitorial supplies, fuel, other equipment, and labor, and so on. The indirect effects pick up and represent those purchases being done locally that can be done within the study area that are needed for the plant to operate. And then finally, economic impact studies generally include what are called the induced effects. And those are the effects of the people who work in the biofuel plant and the people who work at all the other supply chain firms in the supply chain who are supplying inputs, and farmers, and the truck drivers, and so on. They're going to be making money because they'll have jobs associated with this activity, and they're going to spend money locally. They'll buy shoes, they'll make car payments, they'll pay the mortgage, they'll buy food and everything else they buy. What the economic impact models also do is they estimate, okay, based on the higher employment, the new number of people, the number of people you've got whose jobs are supported by this activity, what are the effects of that spending in the community that wouldn't be there otherwise if the people weren't employed or they weren't living here in the community because they didn't have jobs there. So what we considered and what we analyzed with this was the direct effects, in other words, in the biofuel plant, the indirect effects, and that's the effect on all the input supplying firms and the purchases that they need to make from their input firms and supply firms and so on. And then finally, the induced effects, and that's the effect of spending by employees, proprietors at all these levels. And the total effect, economic impact we'll show is based on all that information. I did want to cover a little bit of the major assumptions. As most academic research, or at least economic research, the assumptions really make a difference for what the results are, and so they're pretty important to keep in mind. What we assumed is each biofuel plant needs 35 workers. That's based on the experience in Iowa and other places, kind of ballpark figure. We assumed that the construction, that there were no public funded subsidies. In other words, there were no tax incentives. There was no county grants or state grants or other grants that helped cover some of the construction costs. We also assumed an 80 gallons per dry ton conversion, or 80 gallons of ethanol produced per dry ton of feedstock across all the three feedstocks. And that's based on the National Energy Lab numbers. We also these are some of the more critical assumptions. We assume that the feedstocks that are being produced to support the plants are being grown on unused land, vacant land. Land, in other words, that's not being currently used for corn or soybeans or other productive use, generating dollars for farmers, but rather it's land that's lying vacant or fallow that is otherwise currently not being used. And I'll come back to the importance of that at the end of the discussion, because it does very much affect what the overall effects are here. Another assumption was that the landowners, people who own that unused or the vacant land, are willing to rent that land for this type of production. We assume that the rental rates would be identical to what current market rates are for renting land. They might go up a little bit based on demand and stuff, but we're assuming that we base that on what current ag land rental rates are. And then finally, we assume that all the trucking firms who are hauling the feedstock to the plants are local. The reason why that assumption of are local, back to the slide I showed with the multiplier effects, assuming they're all local means that all those dollars spent on transportation stay within the county, versus if it's a out-of-county, out-of-state trucking firm that's hired, a good share of the money given to them or paid to them would immediately be leaving the community and would not have the effects. And given the the local nature of this type of production, we thought the local firms would be trucking firms is a realistic assumption. Data we got from a variety of places. You can see the list of that information. The folks, the researchers within the New Bio Project were really helpful for us in being able to get the production data and some of the other information we needed. So my thanks to them. Some of that, Kirby and others are on the call right now or the webinar, so thank you for your support with that. Well, one of the first things we had to do is identify what locations the plants would be viable, or where we thought the plants would be most useful to analyze and model. Again, as I said earlier, economic model, the impacts depend really on the structure of the local economy, and so we need to know where they're going to be located. So we used some available feedstock data that was estimated. You can see here at the county level. In consultation with the new bio team, we selected Washington County in the southwest. We selected Berks County in the southeast outside Philadelphia. We selected Bradford County along the northern tier, and we selected Crawford County in the northwest. And you can compare a little bit the size of the pie charts. Crawford County, the switchgrass production, the possible availability is a little bit lower in other areas, but we wanted to have some regional diversity here, and we thought that was a good place to look. If you're not familiar with the counties, a couple of things that are worth keeping in mind. Berks County in the southeast is one of Pennsylvania's largest agricultural counties. Has a little bit over half a billion dollars a year in farm sales. Bradford County in the northern tier is also a fairly large ag county. It's varied from census to census. Sometimes it's in the top 10 counties in the state by value of sales. Sometimes it's just below that. Washington County and Crawford County are smaller, have a smaller agriculture production than in total value of sales than in Bradford and Berks County. Washington in particular, their total ag sales at the farm level in 2012 was $35 million. So it's a relatively small sector in that area. But that diversity of counties and diversity of ag experience we think is useful as well, just because it shows, given across the diversity, what are the potential impacts here. So selected those 4 counties as the locations. Now, based on the availability of the feedstocks, and what I have here is an example for Willow. We did the same analysis for the 2 other feedstocks. We had to calculate how far would a plant have to draw from to be able to have sufficient feedstock to be able to produce the 25 million gallons a year. And you can see here, Crawford County, as you saw the earlier slide, that the availability of switchgrass was generally smaller than in other counties. It's similar with Willow, that we'd have to go around 40 miles in any one direction from the plant to be able to draw in sufficient quantities of Willow to be able to make the plant function. Washington County is 25 miles. Bradford County is 15 miles. Berks County, it was 25 miles. The key behind this, I said earlier, assumption of that vacant land was being used to produce the feedstock, and all landlords of those land were willing to rent. To the extent that the landlords are not willing to rent, the mileage, the distance would be larger. The flip side is, to the extent that somebody is growing corn or has land in pasture or at some other current use that produces agricultural products and they make income off of it, to the extent that they are willing to lease their land for produce feedstock on their land, the economic impact will be less, because their production in feedstock will be offset by the money that, from an economic standpoint, from the dollars that they had been receiving for the production on this land. And so, we've got here the radii that we calculated. In reality, it'll be somewhat different than that, depending on individual landlords and farmers' perspectives, but we think it's a ballpark. Question I see real quick: the 100% is solely based on idle land. It does not include land that is currently produced. So to the extent that existing ag land or currently used ag land is converted and used for feedstocks, the radius, the distance traveled would be less. That would reduce transportation costs. On the other hand, it would also reduce the income, the net effect of income to the farmer, because the farmer would have already been making money from that land, and now suddenly there's changing production, but it would not be all new money to them, the same way as if somebody was growing feedstocks on land that was vacant, that was not currently being rented, it was not being used.
Tim, before we move on, can I ask just 2 very short clarification questions? I'm going to come back to this map real quick. First question is public land excluded in this map? So for example, in Warren, McKean, Forest, Elk counties, the Allegheny National Forest is a major base of potential forest residues there, but those circles are pretty small. So is this excluding federal land and state land?
I am not sure. We didn't use the forest residues in thinning as an option. I don't know if Kirby is able to answer. It's the data that we received from him.
Okay, I saw it in the legend in the blue section of the circles.
Yeah, the blue section is forest residues, but the question of whether it includes public land or not, that I'm not sure of. And I see that Kirby's typing in the chat box right now.
And then, while he mentions, to his recollection, it does not include public land. So that's just something to note to our listeners.
Yep.
The second question I have is, does this exclude existing acreage of these crops? For example, in Crawford County, there are about 4,000 acres of switchgrass already in the ground that would be available to a facility, potentially?
Yes, this does exclude those. Yes, so to the extent that you include it, that some of those feedstocks are already being produced in the county, the economic impact would be a little bit less.
Okay, so what you're depicting is potential for future development.
Correct, exactly, right.
Okay,
and assuming that all the production is produced from this unused land.
Okay, thanks for the clarification. Go ahead.
So we use the mileage to calculate transportation costs. What we ended up doing then in spreadsheet is for each individual plant location and for each type of feedstock. And I've got an example here. This is Willow for Washington County. We calculated how many total acres would be needed to produce that quantity. It's based on kind of yield data and based on the available surplus or vacant land in the counties, how much land from surrounding counties would need to be brought into production to be able to produce that. And so here, for example, Washington County, there's a little bit over 43,000 acres of land in Washington County would be used to produce Willow, 1,600 acres in Allegheny County, and so on. You can look at the numbers. Would be required to produce the quantity necessary for a $25 million plant. We used a census of ag rental rates, and they vary by county to calculate what the payments to the landowners would be. Likewise, used yield data to calculate that and a harvest, and then use that as a way to be able to estimate the cost per dry ton, averaged across or weighted that across all the acres, included the transportation costs, both to storage. Our assumption was that the feedstock would not be taken directly from the field at the time of harvest, but would be stored or stacked at some place on the farm. Could be on the field or in some other location, and only when the plant needed the feedstock was it transported to the plant through the year. And so it calculated the transportation costs there as well too. And so you can see here our estimate was for Willow, Washington County, the per ton cost, a dry ton cost would be about $61. Of that, transportation and storage is about half. The production costs on farm are about $31. And so this is the issue where the mileage, the distance you got to travel, is something that can add up fairly quickly. All right, the question about storage, we debated a little bit how to handle that. The storage costs would exist one way or the other, whether it's done on farm or whether it's done on the plant. And so I don't know to what extent if it would make a big difference if you assumed it was going to be done at the plant versus on the farm. There's still costs associated with that, and so there'd still be some effects there. This is a summary across all the 4 locations and across the 3 different feedstocks, what the cost per dry ton is. You can see they vary, some places fairly dramatically. Berks County, Bradford County, I think some of the costs there are related to the transportation costs and rental costs. Land rent costs are higher, particularly in Berks County, higher than in the Southwest. But you can see that it's a mix of costs overall, depending on what the ultimate feedstock is for the plant, what the cost would be. This is an example of just how we ended up doing the calculations. We calculated for each of the individual, and I apologize, it's not that visible. We calculated for each of the major inputs and supporting services, the dollars generated, used IMPLAN, and then calculate what the number of jobs would be created or supported in each of those categories within the region, and summed those up. And again, as we go into the results, just as a quick refresher, direct effects you'll see are the effects within the plant itself. Indirect are all the inputs, so that's the farmers, transportation, storage, and so on. And the induced is the spending by all the workers and proprietors locally. So what I'll show you is the results from each of the 4 locations. If I go a little bit too fast and jump in between these, let me know, and I'll slow up a little bit. One of the things to notice with all these is the job effects, the direct effects are identical in all the scenarios, and that's because we're looking at the direct employment within the plant itself, and we assumed 35 jobs. The value of the output production varies a little bit across them, and that has to do with some of the inputs and some of the effects that come out of that. The place where there are some major differences is the induced and indirect combined together, and this is largely the effects of rent to landowners, its payments to farmers, buying the feedstock, its transportation, and its spending. And here in this example, Miscanthus, if the plant ran on primarily Miscanthus feedstock, there would be about 251 jobs supported outside of the plant, in addition to the 35 jobs in the plant. For which Switchgrass, 289 jobs in addition to the 35 jobs and the total value of output. The place that the results might be a little counterintuitive is, and this is a place you got to keep in mind, we're looking at the economic impact, not economic feasibility. If you look at this just by itself, you might say, wow, Switchgrass, it's got 324 total jobs, $120 million output. Wow, that's by far the best. That does have the biggest economic impact. It would have the biggest economic impact. But one of the reasons it has is because the costs of production are higher for it. And because of the cost of production, longer travel distance and so on, because the costs are higher, it has a bigger impact, but it also has less of a potential of being profitable or sustainable in the long run. So what's a little counterintuitive when you look at the numbers, when you look at the numbers, you've got to keep in mind smaller numbers from a feasibility standpoint are actually better than larger numbers, because the smaller number means the cost of producing the 25 million gallons overall is less, so it'd be more competitive than the larger numbers. See, there's a question about the acreage associated with the Willow jobs. I don't remember what that is offhand. I know we've got that in the report, and maybe when we get to the Q&A time, I can look that up real quick for you. So this is Berks County. That's just outside Philadelphia. Bradford County, the northern tier. Again, 35 jobs in direct jobs. The induced and indirect jobs varied from 199 jobs with this Miscanthus to 324 with Switchgrass, and output varied similarly across those. For Crawford County, again, identical direct impacts in the plant. The indirect induced a little bit higher than in Berks. The range from 221 from Miscanthus to 302 in Switchgrass. Overall, till 256 jobs with the Miscanthus to 337 with Switchgrass. Part of the dynamic here, if you remember earlier our calculations of distance traveled, part of what you're seeing here compared to, say, to Berks County is travel distance. It's a farther distance, and so bigger cost means bigger economic effects, but yet flip side is, okay, bigger costs mean less competitiveness. And then finally, Washington County, 35 jobs in the plant, and then the indirect induced range from 203 to 309 jobs. overall range from 238 to 344. What you'll see with actually, let me see. I think I've got a. Yeah, what we see across most of these is that Miscanthus. Actually, let me skip ahead here. I'll come back to that in a moment. Here, this is a summary of across those in a range. You can see that Miscanthus, by and large, has the smaller economic impact, fewer jobs. At least fewer total jobs. It's around the same size as Willow's total output, total value of production. From a profitability, competitive standpoint, that probably is more appropriate or better than switchgrass. Switchgrass, again, would have a bigger total economic impact, but that's because its costs per dry ton and transportation, everything combined together, is higher than the other two, and so that creates some challenges it would create challenges for the plants in the long run. Let me go back to I showed you these assumptions earlier. Plant assumptions I'm fairly comfortable with. The farm and transportation are the places where the assumptions really are critical. As I said earlier, to the extent that the feedstocks are grown on existing land, the economic impacts would be less. It would mean the distance traveled would have to be less because the plants would be able to access the feedstock at a closer distance than having to drive the distance that they would otherwise. So transportation costs would be less. The impacts from that would be less. Likewise, the economic effect to the farmers would be less because it would be the dollars from the feedstock would substitute for the dollars that they're currently receiving for whatever the land is used. And so it would be possible for currently used land to be used, but the overall economic effects would be less. The flip side is if the landowners who currently own unused land or existing farmers are not willing to rent the land or use the land for feedstock production, the economic impacts would be larger because the transportation would become more expensive because the plants would have to go a longer distance to be able to get the sufficient quantities that they needed to be able to operate. That the longer distance, higher cost, though, means less competitive compared to other plants producing ethanol, and so that's a big thing to keep in mind. There's also a question whether or not rental rates would go up. If landowners are unwilling to rent the land, would the plants have to increase market the rental rates they're willing to pay to be able to grow the crops, or farmers would have to pay to neighbors to rent the land to be able to grow the crops. That likewise would increase the economic impact to the extent that market rates go up, but it would also reduce the overall competitiveness of the plants. So this is a summary of what our findings are. One of the things that I thought was interesting as a comparison is if you look at the total output on the side. I looked just before the webinar at the total ag sales that the Census of Ag reports for farms in the 4 counties. Berks County in 2012, farms there sold about $529 million of agricultural products a year, which is fairly large. Well, it's 5 times the maximum of any of these. You have to look up for Berks County to be specific. Bradford County, the total sales were $129 million in 2012. Crawford County, it was $116 million in 2012. Washington County, Census of Ag, it was $35 million was the total value of sales by farms in those counties. And so particularly the Washington County, to the extent Bradford and Crawford County, the total economic impact we're looking at here with any of these 3 feedstocks is very large relative to the existing agricultural economies in those counties. And so $100 million is a lot of money. It's particularly large when you compare it to the total size of the ag sector, farm sector in some of the counties that we were considering. So these could have a very substantial, significant impact in those communities. As I mentioned, the full report, it's available on the website. I just uploaded it this morning. You can download it there. I've got my contact information if you have questions you want to follow up with me later. It's also on the report. I also have the New Bio website here if you're interested in more information about that. So with that, let's for questions.
Okay,
can I copy that link in the chat? Yes.
Yeah, it looks like we have a lot of time for questions. So so please feel free to type them in the chat pod, and looks like we can get to almost all the questions today. So the first thing, Tim, do you think you could maybe consult the report to get at this question about acreages? Justin had asked about the acreage associated with the Willow jobs, and I'm sure other people would be interested for the other feedstocks too. Just based on a quick calculation on the slide you showed for Washington County, it looked like it was about 57,000 acres or so, between 50 and 60,000 for sure, at that $61 a dry ton. Does that sound right? And was it pretty similar for other feedstocks as well?
It was fairly similar. Well, yeah, it was. Well, it varied a little bit based on the yields. And I'm looking here. I don't have that in. I do not have that in the report. I can add that I can add that easily as an appendix. Our estimates were 312,000 dry tons required, and so the acreage is the annual average yield divided into that 312,000 tons to be able to generate the number of acres.
Gotcha. Okay. So yeah, Justin asked for a sort of easy to quote estimate of number of jobs per 10,000 acres, for example.
Yeah, I'll track that down, and I can add that to the report easily.
Yeah. So, okay. In that case, we'll move on to another question. So, getting at the cost of production per ton, I have a question about one of the assumptions that was not explicitly listed. It was about that cost for production per ton. Does it account for all capital costs for equipment? I kind of have to sort of be a bit surprised that Switchgrass was rated one of the highest in terms of cost of production, just because it seems like, based on my experience in extension, that Switchgrass is almost a little bit friendlier, since people often have, farmers often have baling equipment, for example. They don't have to make a lot of extra big capital purchases to produce switchgrass, whereas for something like shrub willow, there's a lot of expensive and specialized equipment. I guess I'm curious about some of the basic assumptions for the costs of production. I was a bit surprised to see switchgrass so high.
We for the enterprise budgets, we used those directly that New Bio had put together, that Mike Jacobson and others had worked on. So those did include capital costs. They would have included, or they did include, the equipment. What you're describing is, if a farmer has some of that existing equipment, they would not have that cost as well, and that is absolutely true. We didn't feel comfortable kind of assuming every farmer had that, and so we relied on the budgets and the numbers.
Sure. That makes sense. There's a question from Zane. Your cost per dry ton is about twice that determined in. Oh, he mentions another discrepancy. It seems like maybe some high estimates. He also notes that he doesn't know of any cellulosic ethanol company who could afford to pay $60 to $90 per dry ton. So I know you have disclaimed that it's not a feasibility analysis that you're presenting, but still you have to sort of consider how realistic it would be to square one with the other, right? An economic analysis with a feasibility analysis.
Absolutely. The two are related. When Zane says the costs are twice, you mean the $31 or the $61? Because our estimates, the example I've got here on the screen, the Willow cost is the on-farm costs were around $31.
Yeah, it's possible that Zane wasn't accounting for the transportation and storage costs that you had added in. That would be a much more realistic assumption of cost there to the farmer.
And one of the things we noticed when we were going through the budgets, I can't remember which they were, but there was at least one of the new bio budgets did not include the full transportation costs and storage costs.
Oh, okay.
It was simply on farm, and so we had to estimate and rely on other information to be able to calculate that. By the way, that is another little caveat. The transportation costs, some of those, because it was not available, we ended up looking at some budgets out of Iowa State that calculated for transporting feedstocks and adapted those here. The big caveat is in Iowa, transportation costs, because it's flat, transportation is a lot easier than it is here with the hills and valleys that Pennsylvania has. And so it's possible that transportation costs would actually be a little bit higher here than what we estimated.
Sure. Okay. Thank you. There's another question here. Kirby is wondering how sensitive the results might be to related to publicly funded subsidies. So you mentioned that publicly funded subsidies were excluded from this analysis. In a lot of cases, when there's a plant being built or any kind of new bioenergy activity, it often depends very heavily on some kind of subsidy. So he asks if you could include those in your model, possibly as part of a cost-benefit analysis.
They could be done. I think that the subsidies would make a difference from a financial feasibility, competitive standpoint. From an economic standpoint, they really would not make a difference. And the reason why is there's a distinct difference to economists, at least, between economic analysis and financial analysis. The big distinction, and this affects here, is financial analysis is you're looking at the numbers from the perspective of an entity, a farmer, a firm, a local government, a consumer, trying to figure out what is the cost that they're going to pay. And it's simply looking at from their perspective. So from a subsidy standpoint, if there are subsidies that reduce the plant construction costs, that would reduce the cost for the firm, or if it helps subsidize farmers or helps subsidize the transportation, that would reduce the cost and make it more profitable for the firm to operate. From an economic standpoint, an economic analysis standpoint, you don't consider or you don't focus on who is actually paying. You're looking at the total cost regardless of who is going to pay. And so if there's a subsidy, say of a $30 million subsidy or $10 million subsidy going to the plant, that reduces the plant's cost to set up by the amount of the subsidy, but yet those dollars are coming from somewhere. And so those still are a cost to somebody. They still are an expense. And so they still need to be, whether there's a subsidy or not, the cost of establishing the plant is the same. The difference is who is actually paying that cost.
Okay, thanks. I'm going to ask a for non-economists everywhere question here. So, you mentioned there's an important distinction between a feasibility or a cost analysis and an economic impact analysis. And it seems like, something that's kind of shaken out of this is how it seems that with a higher costs and less feasibility translates to actually pretty high economic impact. A lot of dollars involved, a lot of jobs affected. So, is that sort of reflective of higher value products are more impactful and yield more, but must be higher value in order to be feasible? I guess could you sort of just touch on that a little bit for the non-economists in the audience now?
I think I understand your question, and if I don't answer it, if I don't answer what you're asking, ask me again. The distinction between the two is an economic impact analysis looks at, given what you're spending, how does this circulate through the local economy? That's the emphasis. And so with this, we looked at, given the expected costs, given the expected where the dollars are going to go, how much goes to the farmer, how much goes to transportation, and so on. How would those dollars then circulate, multiply through the economy to generate additional jobs, additional income, and so on. And so if dollars circulate a lot, it can be a big number. If you spend a lot of money initially, it can also be a big number. But that's a separate question. That's a separate issue of, is something going to be profitable or not, or competitive or not? And for something to be competitive, you want the cost to be low, so that you can sell ideally less than your competitors, or at least at about the same rate as your competitors, so that you can make a profit and remain in business, rather than being undersold or not being able to sell at a price where you can cover your expenses. That emphasis on low cost for profitability is counterintuitive from an economic standpoint, economic impact standpoint, in that bigger costs mean bigger impact, smaller costs mean smaller economic impact. But they're looking at two different things.
Yeah, that's very clear. I just kind of wanted to clarify that point. Thank you for doing that.
Okay.
Okay, we have a couple other questions. So Zane clarifies that he wasn't accounting for the transportation and storage costs, but he mentions that the storage costs do appear high, a little bit high by his estimate. He asks about the length of time for storage that you've estimated.
Less than a year, and I think we might have pulled that from, there was an Iowa State enterprise budget. I believe we pulled that, the storage cost, directly from that. I believe that's where we pulled it from. And it was less than 1 year.
Okay, thank you. Justin notes that the $60 to $90 estimate per dry ton for the plant gate. He mentions that $60 would be, by his estimation, Justin, by the way, works very closely with Willow in New York. He mentions that seems very reasonable to him, that 90 would seem fairly high. And that double transport and storage costs do seem a little bit high to him, and certainly not optimal. It would, I guess, then translate to a conservative estimate in terms of feasibility, and maybe a less conservative estimate in terms of economic impact.
And I talked to, after we did the analysis, I talked with Dave Swenson a little bit about this. And again, this is not a feasibility analysis, but based on his experience in Iowa, I was just curious to know: are the numbers we're coming up with in the ballpark of potentially being feasible? And he thought definitely that they were. That they're not. Some of the numbers, as Justin points out, are high, but other numbers that we came up with. Based on the assumptions that would go for travel costs and transportation costs and for production and stuff, that the cost per gallon is within the realm of possibility within the market. So again, this is not, don't take that as absolutely these are going to be profitable, but it's not, by and large, the numbers are not so outlandish that there's not even a point of being able to consider this as feasible. It is within the realm of feasibility.
Okay, thanks. Yeah, I think a lot of us come with individual or anecdotal experience working in a lot of these markets, and it's just really interesting to see numbers that are different from the ones we usually work with, and it's very useful to see these kind of regional analyses that pull together a lot of information to maybe give us a reality check about what our expectations might be. Mm-hmm. So a question I have is kind of in terms of next steps. What do we do with this information? I'm wondering what the next steps might be to incorporate either current production or unique features about these specific counties or areas to calculate a closer to reality impact. So someone had already mentioned subsidies, but I can also think of some examples like the necessity to use special trucking route restrictions due to high Marcellus shale activity, say in Washington or Berks County, where that's really big, or for the Crawford County example, to incorporate Ernst's current switchgrass acreage in that county, or something like unique regional access to cooperatively owned or subsidized equipment. Would that be a logical next step for these data?
I think so. That you can see from the slide I've got on the screen here, transportation storage is about half of what the delivered cost would be to the plants. And so I think it's really critical to identify accurately what those, as accurately as possible, as what those would be. And so, one of the ways, if there are specific counties you're looking at using GIS analysis to calculate the transportation, the specific routes, rather than, we drew a radius with a compass. We did not consider, the actual travel routes that the trucks would have to take. I think a related, absolutely critical question is, to what extent would landowners or farmers be willing to convert over? Because that very much influences the distance required to be able to find sufficient feedstocks to make these go. By the way, as an aside, one of the things with input-output analysis, which is what IMPLAN does, is the analysis is linear, not quadratic, which means if you had, for example, a plant that instead of being 25 million gallons a year was 50 million gallons a year, you can scale up and down the results pretty much as a straight number. The place where it gets a little funky is with transportation, because that would influence how far you've actually you got to go. But there are ways that maybe another thing to think about is, particularly given if the assumption or the focus is going to be largely land that is currently not being farmed will be converted over for use. Based on some of the distance estimates we were having, it looks like there are some counties like Crawford County, it might not be worth considering a 25 million gallon plant. It might be worth thinking of a plant that's a little bit smaller, that's more consistent with the feedstock availability within the area. Again, based on our numbers, the transportation storage is about half the delivered cost. Ways that you can reduce either of those would make a significant difference for what the plant gate cost would be, and thus the overall feasibility of the plant.
Thanks. I have one last question for you, but if anyone else wants to type in a final question for Tim, please do it at this time. In the meantime, I have a question. What should a local government official, a county commissioner, for example, do with your results?
I think I would hope that the results would be very helpful for county commissioners, other local officials, to understand that there are some major economic advantages, potential associated with having a plant like this and this activity going on. We have estimates of the number of jobs. It's a good number of jobs, and particularly in some of the counties, compared to the current size of the agricultural economy, it's a very big overall economic impact in terms of output. So, it can be from an economic standpoint a real benefit to the community. I think that argument's fairly easy to make. Indirectly related to this, I'm sure you're already talking along these lines, but to have the land in this type of agriculture does help keep that land open and avoid sprawl, and there's a whole bunch of environmental and aesthetic and quality of life benefits for having an activity like this going on in the community, simply because it helps keep farms in farming and helps support the local economy.
Thank you. Not seeing any final questions, I'll kind of wrap up here, I guess. Tim, thank you so much for going over this study. What a great overview. And if you could please copy the link to the report itself in the chat pod so people can consult it. And I'll also post it with the recording of this webinar. I will be converting this webinar to a YouTube recording, and it should be up later today or later this week. So if you want to go back, if you missed anything, or if you want to recommend to a friend or colleague to watch this webinar, there will be a recording of it available through the New Bio website. Tim, thank you so much, and we appreciate everyone's attendance today.
Very good. One quick comment. I appreciate I appreciate all the questions, but especially the question about the acreage required. And I did not realize until that came about that we did not include an appendix with that information. And so I'll add that. It might take a couple days before I'm able to add that and get it uploaded to the website, but we will get it up there so that those of you who are interested in more of that technical detail will have that available in there. So, thank you.
Thank you so much. Have a great day, everyone.